In this video, we are going to see how to convert a block diagram into a signal flow graph. So there are certain Today, we are going to see how to convert a block diagram into a signal flow graph. So sometimes it is very difficult to use the rules of block diagram reduction to find the transfer function of a system. So it is better to use the signal flow graph for easy way. So we'll see how to convert a block diagram into a signal flow graph to determine the transfer function of a system using Mason's gain formula. So the procedure involves 5 steps. So the first step is in the block diagram, we have the input, output, the summing point, branch point. So we are going to represent the input, output, all the summing points and the branch points in the form of nodes. So usually the nodes are represented in the form of small circles and they are numbered as 1, 2, 3, etc. So after identifying all the summing point, branch point, we are representing all those in the form of a nodes and we are numbering it. So those two are the two steps. And the third step is after representing all the nodes, we are going to draw directed line segments so that it interconnects all the nodes in the in the forward direction. And after indicating or joining all the nodes by means of directed line segments, the next stage is we have to represent all the feed forward path gain and the feedback gain in the block diagram. So these are the 5 steps in the conversion of a block diagram into signal flow graph. So now we are going to see a problem how to convert a block diagram into a signal flow graph and later to convert or later to determine the transfer function using Mason's gain formula. So when we look into the diagram, we could see that there is an input R of S and the output is represented as E of S. So the input and output are represented as two nodes. And followed by that, we have 4 summing points. So there are 4 more nodes. So total there are 6 nodes, and along with the 6 nodes, we are finding that there are 3 branch points. So totally in the 6 plus 3, which means in the signal flow graph diagram, it includes 9 nodes. So initially we are representing all the 9 nodes in the form of a circle, and we are numbering it from 1 to 9. And after numbering it, we are going to draw directed line segments from node 1 towards node 9. And after drawing the directed line segments, we are going to represent all the gain, the feed forward gain as well as the feedback gain in the signal flow graph diagram. So when we look into the diagram, we could see that across the node 3 and 4, we have a feed forward gain represented as G1. So we are representing it in the signal flow diagram. And the next is between the node 4 and 5, we are finding between the node, 5 and 6, we are finding that there is again a feed forward gain G2. We are representing it in the signal flow graph diagram. Between 6 and 7, we have a feed forward gain which is represented as G3. G3 is also represented in the signal flow graph diagram. And again, when you see, we have between the nodes 5 and 7, we have a feed forward gain G4 that is now represented in the signal flow graph diagram. And now there are 3 feedback gains. So it is a negative feedback. So when we are representing these feedback gains in the signal flow graph diagram, all those gains should be represented in the form of a negative sign. So here between the nodes 9 and 2, it is a unity feedback. So it is represented as -1. And now between 8 and 2. And next, if you see between 8 and 4, we have a feedback gain of -h2. So it is represented. And now between the nodes 6 and 3, we have a feedback gain of -h1. So this is also represented. So this is a simple way of just converting the block diagram into a signal flow graph. Once this procedure is done, the next stage is we have to proceed as per the usual way of finding the transfer function using Mason's gain formula, which means we have to find the number of forward paths, and we have to find the number of individual loops. We have to find or identify all the two non-touching loops and so on, and then find the value of delta, and then we have to apply everything in the formula of the Mason's gain formula to determine the overall transfer function of the system. Thank you.